Hello, today is July 3rd, 2018. This is the SIG cluster lifecycle standard meeting. We have a couple of agenda items we can start to go through, and if folks have other things they want to discuss, feel free to bring them up. The first thing I added to the list for today was I want to have a conversation on thoughts on promoting dynamic kubelet configuration to be defaulted or not, and underneath what scenarios. So I think Fabrizio brought up the point that it makes sense to default it for new clusters, but not necessarily for clusters that were started on 111. Thoughts there?
To clarify, so like the idea is that to only greenfield clusters get a dynamic config by default.
Yes.
And any upgrades or any other Frankenetis will not get it by default.
Well, any 111 rendition will maintain its previous configuration file apparatus that it does on the join, because to pivot it would be tricky. I don't know. I wouldn't say tricky. It'd be.
So it is backwards compatible.
It maintains the previous version, previous rendition. You'd have to literally start a new cluster. If it detects that you're using the old configuration file, it would just continue that process.
Yeah.
That was the proposed idea from Fabrizio. I don't have strong opinions other than like if we're going to enable it, we need to add a lot more testing.
Yeah. So we kind of have this thing ready because you can at any time do a kubeadm upgrade node config, and that will fetch the latest stuff you have. And well, there we go. The problem that I see with regards to enabling the feature is that we don't, kubeadm is a one-off. It's not a controller. So if you ever should update the config map, or like the problem here is kind of the topology, I think. So right now we have kind of every kubelet looking at the same config map. And if we ever then restart that config map, even though, I mean, and I consider the success scenario the most dangerous, because if we have the success, some whatever valid reconfiguration, every kubelet is going to restart as soon as possible. If it's faulty, nothing's going to happen. It's just going to be a condition that, well, there is a faulty configuration that I'm supposed to run, but I can't. I'm using the last good version. But if I actually have the valid reconfiguration, everyone is going to start. So I think that it's probably out of scope for kubeadm to do the orchestration that, well, now we migrate to the new version, repoint one kubelet, then repoint the other kubelet, then the third, etc., etc. So, yeah, I'm a bit skeptical.
Well, I think it's a little bit of a dangerous. It's a kind of a dangerous feature. It's like a foot gun, and if you opt into foot guns, you buyer beware, right? Like, I don't own a gun in my house, so the chances of me accidentally shooting something are slim to none. But if I owned a gun, the probability would be much higher. So it's kind of the same analogy where, like, if you opt into doing this thing, we still provide you the means by which to do it, but it can potentially break a cluster really easily. And I don't know if I feel comfortable without an ingest, a certain level of vetting to occur underneath all user stories before I'd want to enable it by default.
So I'm wondering what we're gonna get. Because when I earlier said we wanted dynamic kubelet configuration, what I actually meant was the static like flow
But
that we are
if I
making
may add
dynamic.
something,
Sorry.
Go ahead, Fabrizio.
Yeah.
I think that there are two problems. One problem is enabling this feature on existing cluster, and here we can do it automatically, but it is risky, and I don't like then this feature get applied without the administrator of the cluster getting the full control of this operation. And the second is, once we have the configuration, the dynamic config in place, is how we manage the change of the dynamic configuration. And if we should keep this change linked to the upgrade, or it is a separate operation. With the regards to the last point, I think that the people from Signode make a good job in doing a recommendation in keeping the config map immutable and to change it in a kind of rolling upgrade path. And I think that we have to keep this best practice, and if not enforcing, could mean at least to recommend in our documentation.
So I'm leaning towards just having as an optional feature that you can buy into. I like the current apparatus and mechanism we have today because it's very explicit, right? I'm a big fan of explicit versus implicit because the operator knows what they're doing. They'd have to explicitly opt into this feature, and there's less potential for catastrophic events to occur in this scenario. We can always document and give people the tools to do what they need to do, but make the common case really well defined and easy to understand. I think the user story for dynamic kubelet configuration on by default is kind of fraught with peril. That's my opinion of it. I mean, people can view it in a different way though, and I'm totally open to those opinions.
So yeah, I mean, I'm happy with the current situation. That because I don't see exactly what dynamic kubelet configuration really gives us at this point, because still we do the version branching of the config map. So even though we used dynamic kubelet configuration in order to like segregate the kubelets, so that if we introduce like a new security feature in 1.12, it's not going to affect 1.11 kubelets running in the cluster. And we already do this, and if we consider the dynamic kubelet configuration enabled, and we upgrade to 1.12 a kubelet, we still have to repoint the kubelet to the 1.12 configuration. That is an operation, and it doesn't really matter if we download the 1.12 configuration to a file on disk, or if we patch the Kubernetes API. We need to do one operation anyway that is about to be executed on the node side for the user. So we don't gain anything really, or not much. Like if you consider without upgrading the runtime reconfiguration scenario, yes. But there we have one. But again, then, well, then you need to find some way like to orchestrate so you don't blow all kubelets at the same time.
I think there's a way to make a philosophical weighted way how we can approach these types of problems. Is we can say we will always err on defaulting towards immutability, and mutability is an opt-in type of behavior. Right?
Sorry, Okay, so it's an opt-in.
So there's a way we can generalize how we approach these types of features. Like a general way is we could blanket statement like KubeADM will always err on the side of immutability, right? Like we do an operation, it's set up for success in perpetuity, right? We will not err on the side of mutability, which is basically like we provide this way of auto-changing the environment. We'll give you the tools to allow you to do that, but that's not the defaults that we'll provide for you.
Yeah, that's kind of true for everything I can think of. I mean, obviously the controller manager and stuff mutates the cluster, but that is like expected. So
it mutates the workloads on the cluster. It doesn't mutate the cluster.
Oh, yeah, exactly. Yeah, you mean explicitly the cluster itself. And that is also, if we go for that, we also kind of opt out of self-hosting automatically, because that is basically like mutating stuff. Like we have three masters. We update the deployment. Kubernetes updates itself, so it's going to roll out the new APIs of image on all three nodes, while KubeADM is only executing on one. And if we say that we won't mutate where KubeADM isn't running, then that's like a non-starter.
But again, this doesn't prevent people from, we want to be able to allow people to do their things, but that's not the default. If we just say we default on the side of immutability, we provide the knobs for people to do what they want to do. Because I always want to get out of the way of power operators, right? If they want to do something, give them the tools.
Cool. I'm happy with that. Let's see if my internet connection is stable enough to have video. Any other comments from the SIG?
The next topic I had was just the general naming. This one could be really short. There was a general conversation piece had in SIG architecture and in steering that we wanted to eliminate the name of master across the code base where possible and use the term control plane. If we can use, and this is kind of more of a request as well as a kind of a PSA about the history behind it, we should probably change the name of the master join scenario to be control plane join. Questions, comments there?
Well, if they want us to change it, I mean, it's fine. It's not that confusing to the user to use control plane in this case.
I'm also fine with like generally. I mean, we have in the KubeADM init output, for example, we use the term master, and a fair amount of times in the documentation. But that is not something that blocks us from changing the like Cobra output. Shouldn't be that hard.
Yeah, I know on the website we've been using control plane over master recently. I'm not sure if people in other SIGs are doing the same. I don't really have any insight to that. So
it's primarily this SIG that uses that nomenclature because it's all about the deployment. So we are the largest group that requires a change, and if we are going to add new features, we should make sure that we use the same naming for these new features in perpetuity. Yeah.
I've definitely been leaning towards control plane for a while, which means it's now mixed. I would imagine the code base is fairly mixed on control plane and master.
You turn on your camera, Justin. So usually that means you want to say something.
No, I was just Yeah, we still use the word minion in the like on all our bring ups in like cube up, for example. And it is a difficult thing to expunge. I am certainly in favor of like renaming the UI things. It's the system level things that will likely persist for longer. Like I was doing a control F in KubeADM, and like there's a master configuration API type or kind.
Yes, we're about to rename the master configuration to init configuration. Is it only my screen that froze, or?
No.
No, okay.
So we should try to do it, but it's going to be tricky.
Yeah, I think just on net new things, as we see new things roll in, we should try to adjust appropriately over time.
And if we have the opportunity, that's great, but it will be probably many years, I suspect. There is another thing we should leader is another word that I think. So I guess the question is, what do we dislike about master? Like there are two things that people sometimes dislike about master. One of them is that there's a dedicated node, the concept that it's a dedicated node, and the other one is the sort of political correctness master slave type connotation. If it's about obviously for political correctness, we should just like switch to other words. But if it's about the idea of a designated node, leader is often a more correct term. If, for example, we're talking about joining, you join a leader, right? So if we have to specify it, you don't really join the control plane if you're part of the, I don't know. Anyway, sometimes the word might be leader. It depends what we're trying to achieve, or why we're trying to achieve it, rather.
Yeah, we can bike shit on this more, but I don't have strong opinions. I just know that control plane was the term designated within SIG-Arch and steering as the common denominator for how we converse about these things. It's brought up in both documentation and as well as communicated widely across different SIGs.
Yeah, I'm in favor of like just saying control plane, but yes, I do. But it really depends if people think of the like master as a dedicated node, or if we're like having it as in KubeADM that we have a taint and you can technically untaint it, or if we do as cheeky, I think that don't register the node with the. You're muted, Justin, but
I was mouthing control plane.
Yeah. So, yeah, but I think like the most common replacement, like naming for or other naming, is control plane. So I'm happy with us doing that, and that's master configuration is going to be renamed init configuration. So we're going to split master configuration to init and cluster configuration.
Great. Any other comments?
And it's backwards compatible, Justin, yes. So you don't have to worry.
Yeah, I have questions about the last thing that Lucas said, that we're splitting the two configs from one.
Yes. But that is in the config proposal thing. I could do a walkthrough or something if we have time.
Yeah, I think you have two proposals. I only put one.
Oh yeah. Well,
one is the component.
More than one, yes.
Yeah, the other one is the V1 beta 1.
Yes.
I think those are the next topics anyways.
Okay. Let me...
I'll update the doc while you go ahead.
There we go. Okay, so this is like, I've been a bit frustrated on the like component config isn't proceeding as quickly as we want it to. The development there, and we don't have much unity between the component configs, or next to nothing. And now Mike Toffen has worked a lot on the kubelet side, and it's really improved and proved to be working exactly as it should. And in the end, there are differences, but there's a lot of similar stuff that we use for the rest of the Kubernetes API machinery. So it's not that different from what other APIs we have. But basically, the next step here is that we now have all our types inside of the Kubernetes core. And in our Kubernetes configuration right now, we embed you could think of them as private, as they're inside of everything that is inside of Kubernetes. Kubernetes is kind of private from a vendoring perspective. Things that are in staging are like public. And as component configs right now are private, as they're inside a core repo, people have a hard time vendoring them. And if we're ever going to split out Kubernetes, which uses the component configs of different projects like the kubelet and the kubeproxy and eventually all the control plane components, we have to have these in a staging repo. They should be in the same way as we have Kubernetes /case.io/API with the external types in a staging repo, only the structs. In the same way there, we want to do stuff for component config. So the proposal, which is still in discussion, is to create a new repo, case.io component config, which hosts the external types of all the component configs. And first off, let me see if I can share my screen.
So I'm going to the fragmentation of consumption of API objects across these multiple repos, from an external consumer perspective, as someone who both works on the core as well as consumes things outside the core, is mind-bogglingly complicated, overcomplicated. Like most other things have one SDK, right? Like if I'm going to program against Amazon, right? If I'm going to do something against Amazon, they have a single SDK that I can reference, right? And it's well-defined, it's well-documented. We are a never-ending shifting sea of API groups and types and versions, to the point where it is obtuse, even to people who work on the core, right? Like these things should be super easy. And I question why we'd want to break it into a separate thing versus trying to rally around, this is the thunk, everything you need as a consumer. This is everything you need to vendor. It's all in one location. I don't want to vendor 12 things. I want to vendor less things.
I hear your pain. Are you talking about the vendoring issue or the movement of package imports primarily? Because I think that they're different things.
The package imports and the staging goopery, I don't particularly care. As long as all I care about is like, what tools do I need as a consumer of this outside of the core, and what is the UX experience from a developer? And I am someone who has worked on the core since Epoch, right? And so, and I find it confusing. Like it's totally confusing.
It did get better recently because they've started tagging all the downstream the staged repos, and so you can now, with dep, you can explicitly specify all the tags and you get a consistent set without a horrendous pain. But I think the replacement for dep will hopefully be better, but I have yet to personally try it.
So I think here that issue is more, if not a steering committee issue, an general API machinery thing. But I think the flux here we're seeing is because we have so much code inside of the core monorepo that it's hard and it's taking a long time to move stuff out into logical places, as we're trying to do. When we have all the things in different composable staging repos, we can create like SDK aggregation repo or whatever that pulls stuff together and has nice user interface or whatever. But before we even can do before we even can do that, we need to move stuff out.
I'm laughing because we're literally breaking apart the repo to then have these separate things to then come back together to this integration point. So it's
but that is because we have to make stuff composable, because now it's now we can't, now we have to render all of Kubernetes or nothing. But if we're only making an aggregated API server, we only need the API server parts. So then we only render that. If we're using client Go, we can only use client Go. But if we want a mega SDK with all of the Kubernetes, we want to make component configs, we want to make like talk to the Kubernetes API, we want to create our API server with an operator toolkit, and we want to reuse the controller framework, etc., etc., etc. Then we need everything, yes. And then we need like one mega SDK. But it's composable for a reason, so that we can, the API machinery can be used for, API machinery repo can be used for anything. It doesn't have to be Kubernetes stuff. Client Go has its like specific use case. The API server repo is creating whatever API server you want, etc., etc. So I'm not, yes, it's confusing, and yes, it's in a state of flux, but I do think it gets a lot better every time.
okay. Let's move on to the gritty here. I don't want to railroad you too much because there's broader conversations that affect everybody.
Yes, and so for this thing, the kubelet is fine. It has all the stuff needed. Currently, both the internal and external API versions are in package kubelet APIs, kubelet config. The same thing goes for the proxy, which is so this is like the current best way of doing it under its package and its components and APIs. But as we all know, the version is still alpha. The API group embeds client connection configuration, which is wrong because it should be shared among components, and it doesn't do flag precedence, as we know, and the config file loading is not tested. And then we have the mono component config API group, which is like just been created a long time ago, like near epoch, and nobody has done anything to it, which is something we want to change now. And it also embeds the shared structs, and we should move stuff out here. The control manager is next to the scheduler. The Kube API server doesn't have at all component configuration, so we can't do anything here. The cloud control manager is also in package APIs component config. So the goals of this proposal is to find a home for the component config API types hosted as a staging repo. In order to make these types consumable from projects outside of Kube and also from different parts of Kubernetes itself. For example, whenever we break out kubeadm to either a staging repo or like a fully another authoritative GitHub repo, we need this. And then also do as kate.io/API and split internal types from version types. So version types are going to be in the public case.io component config repo, and the internal types are going to be left in case.io package kubelets APIs kubelet config, for example. So here are only the API, the internal APIs, and in the new repo, new staging repo, the external. And then we can remove the monolithic component config that was never, it was never used properly. And we don't, with this proposal, we're not saying we should graduate the, for example, kubeproxy component configuration. That is a follow-up, and that is something, in the end, yes, the SIG network approvers have to do. This doesn't mandate any structure for the components itself. It just says create a generic location for shared stuff, for example. And this proposal won't change the components itself either, other than import renames.
Quick question.
Yes.
Is this basically about being able to configure any of these Kubernetes control plane components using the API, or there is a different goal about this?
Not using the API, but eventually we want to have every. So Mike Tolfin has his document here, why we need version config files, and this is like what we want to do. We want to say component like the API server or controller manager or scheduler or whatever, and give it a --config and give it version configuration.
Right, but what is the use of that version configuration? Basically, we should be able to dynamically configure this control plane component. Is that the goal?
So the goal is to be able to even know the structure of this configuration. So how can we write API server component configuration file without having access to the structs?
It's basically a unified configuration file that could be stored as objects and then on the API server, but doesn't need to be dynamic because we don't use the kubelet configuration dynamically. But it's
right. So I mean, the goal is also to consume this configuration to configure the API server, right?
To configure the components, yes. But yes.
Yes, configure any component statically. There's nothing dynamic. I mean, dynamic kubelet configuration is one thing, yes, but it kind of only makes sense for the kubelet.
I see.
So this other components is just like read the bytes, like consume the bytes that I give you.
I see. So this is not dynamic configuration of other components.
No.
Yeah, it's basically well-defined versioning semantics around configuration for the components.
Yeah, it's just let's not do flags anymore. That is like that is what this proposal is striving towards, and it's an yeah. And here I have as an own goal. This should not be confused with dynamic kubelet.
So when the API server starts, it basically, where will it read the configuration from?
From a file.
Or from a file, okay.
Yes.
And then the configuration is also stored as an API endpoint.
No.
It can be stored as a config map, typically.
I mean, it can be. It is. This has nothing to do with API endpoints. There won't be any API endpoints for this. The API server won't recognize these. It's just for the component itself. It can recognize the bytes on disk using a version schema.
Cool, thanks. Yeah.
Memory. Cool. So, yeah, and now it's like the proposal is to have this kind of structure, move stuff out there, have the internal types inside of the core repo, create a shared types package with stuff like client configuration, client connection configuration, and leader election configuration that is shared to multiple components in a generic package, and remove the monolithic component config group. And I also have more in depth, like what should be done for every component. I have D from this SIG helping out with the scheduler, and another guy, Stuart UI, is doing the controller manager. I hope that Mike Toffen can do the kubelet. It's like just a package move. Everything else works really flawlessly. And as the API server doesn't expose a component config, it's an ungoal to actually create the component config at this time. But it's a goal for it to work with this, with the same. Everything we do here should work with the API server once it's available.
Is there any plan to deprecate a set or a subset of flags on the components? Because right now there's duplication pretty much. It's one for one component config, the flags. Sometimes people secretly sneak in things here and there, but whatever. I think a long-term possible objective might be to eventually deprecate flags as a goal, or a chunk of the flags. Some of them you still want to have the overrides for, and that makes perfect sense. But there are too many flags in the components.
Yes. So that's definitely a goal long term. And also there's a lot of one goal is also to minimize the amount of duplication. So if we go and look at the kube proxy configuration, we have stuff like bind address, health C, bind address, metrics, bind address, enable profiling. This is kind of like generic to any server.
They're like type meta, but for component config.
Yes, exactly. So that is the generic stuff, and also whenever the API server gets its component config, there is going to be this generic API server that has this kind of stuff. There's a lot of different parts of all our APIs that we now have as flags, so then it's duplicated all around that we're going to unify eventually. But for that to actually even be possible, we need this kind of well-defined structure of all stuff component config.
All right, so here's the kicker, Lucas. You're going to be gone for a while, right?
Yes.
Who is going to drive this forwards and make sure that there's consistency across the components and the changes?
So we'll see. But Stefan from API Machinery is also going to drive this. Mike Toffen is on vacation, but I'm pretty sure he's also going to help. He's been interested in, obviously in this stuff. I still haven't got a firm answer from the top level approvers of this, and then I have a couple of contributors that I've signed up. I've synced with them, and they signed up to actually get the code out needed for this. And then I'm gonna have. I will have some free time. Like if I'm going home from military service, there's gonna be on the train 6 hours or something every week. Or no, 12 hours every week or something. So maybe then I'll have time to review Kubernetes PRs. So I'm going to be in the owners, at least in the owners file of this thing. But it's definitely I wrote this now when I still had time. So we can get some consistency between the people working on it, because there have been a lot of confusion. If we have the canonical description of this is the plan, it's way easier to actually execute on it.
I think this needs to be, just being honest, I think this needs to be owned by a SIG or a working group that can cut across. It makes sense that the working group or SIG would be part of both API Machinery as well as C cluster lifecycle. But to make sure that ownership propagates over time, and that way owning SIGs. We should do the aliasing from Epoch though.
Yeah.
Eventually I don't see this being owned by SIG API Machinery at all, once it's finally said and done.
Yeah, we had a conversation more than a year ago, I think, in this SIG, where we had also people like Brian Grant, and on the call, and we discussed where and who should be owning component configuration. And I think at that time we said, let's do it in C class lifecycle, at least for the time being, to unify stuff, and because we're the ones responsible for configuration, configuring the components, kind of. That is part of our mission. So then we also kind of should be responsible for enforcing consistency. And yes, there will be a lot of API machinery work in the beginning, but after that, it will be obviously up to each SIG hosting a component to maintain their own structs. But I think it falls under our plate to actually create the structure, say this is like how a component configuration API package should be created, or like be maintained. And we have 3 documents that are linked here. We have what Mike wrote up a long time ago. That is a lot of considerations on how to like think about configuration. Mike's more actionable. Mike Toffen. Mike Toffen's doc is more actionable. Like, okay, you have a component. How do you actually code it to support component configuration? This is here. The next step is here. How to split the code out in logical ways to actually make it reusable. And then after this, we might do stuff like that are non-goals here that we want to execute on later, that graduate the IP, kproxy component config. But that again is SIG network specific. It's not our thing to graduate the structs. I don't know, do you think that like that responsibility sharing makes sense?
I think we can figure it out over time. I think we'll have to. I think this kind of lives in, when I was thinking about it, it kind of lives in sub-project land. It's like a piece that kind of is unto its own, right? And usually stuff that's in unto its own is considered from the larger organizational structure as a sub-project.
So we haven't resolved all the conversations yet. I announced this yesterday. And we also might do stuff like move the config really close to the components. So then we'd start moving components out to their own repos or whatever, and then keep the config close there and just ditch the mono repo, or like the one repo with all the component configs, and instead do multiple repos for every component where both the component and its configuration lives. So that is not fully resolved yet. We might go either way before actually submitting the KEP. But at least starting this conversation, finding a solution, and it's not that much of a code move. I mean, obviously there's something, and a couple of PRs per component, maybe 2. But the objective is for this code move to be done by 1.12, because this is really internal, it's changing nothing to the user interface, but it's gonna pave the way for the rest of the components actually starting to use code and use component config properly.
But these are going to be some big PRs for the component changes, I think.
Depending on what you define as big.
Well, I mean, you probably have to change a lot of things to move out the configuration to I don't know. That's how I feel about it. I think these PRs are going to get a lot of comments, and we can potentially hold the transition easier to make it easy.
I'm not very afraid of the size of the PRs. I don't think it's going to be that much because, I mean, there's a types go file. Most of the API machinery stuff looks the same for all API groups. So if it just matches the standard, okay. The types should be one-to-one. There shouldn't be any changes. And then there are a couple, but not that many imports of the component configuration because it's not used widely yet.
Yeah,
So
hopefully it's feasible for 112. I guess that's my point.
Yeah, I definitely think it is. Okay. Any more questions, comments, concerns about this?
I was going to ask Lucas, are you going to have internet on the train that you mentioned?
Yes, I'm gonna.
So you have internet in the whole Finland, like it's a big area.
Yeah.
That's very nice. Excellent.
Yeah, I hope for like maybe 10 hours or something a week at least. So, well, we'll just see. But hopefully I'm not gonna be like 100% away, because I would like to get distracted by this. Not have to think about the military stuff. Try to the 112 backlog. What's the sixth vision? I think we should move this first, and then I'll quickly after this go through the master config. Just the three important points. Can you speak to this, Mike?
Sorry, was that a question for me?
Yeah. Can you speak to the stuff you added to the agenda?
Right. Basically, my question was like, is there a tool that basically covers doing Kubernetes upgrades in a rolling update fashion? And basically, we deploy Kubernetes using Puppet modules, and it's basically a pain to do Kubernetes upgrades for a lot of reasons. And we are basically exploring what other new tools are available now since we last explored this. And is there a tool that allows to bring components of Kubernetes across minions and masters in a rolling update manner? Is there a one that basically handles HA and things like that? So what's the state of the art today right now?
I mean, I can give you some background, which is there were a number of tools separately that did this. Like I obviously work on COPS. GKE is one, which is commercial. Like the commercial vendors all have one. I think there are others as well. I think there is a work to unify those in the cluster API, which is a sub-project of this SIG.
Right, I saw that. Yeah.
So I think that's where the focus is, because once we get that into sort of API addressable form, the hope is that a rolling update would be standardized across the various clouds or bare metal or whatever it is. So for example, today COPS has code specific to AWS to do like the instance teardown and bring up as part of a rolling update. And the hope is that in the cluster API, there will be a machine controller that will have a specific binding for AWS or GCE, but then the rolling update basically operates exactly the same way, regardless of the machine implementation. So the cluster API is, as I understand it, where it's at. And my understanding is kubeadm, because it operates at the node level, wouldn't really be addressing this, that will be the coordination of a rolling update will take place at the cluster API level. I don't know if anyone wants to comment.
I totally agree on that. kubeadm does the node specific
being developed. Are they all different tools being worked by different SIGs, or are we converging on a single tool that will allow us to install Kubernetes across bare metal and public clouds?
I think we're converging on a single API, and then there will always be a different. I believe there will always be a different machine controller for AWS than there would be for bare metal. But the hope is that the piece which does that one binding to your provider of machines will be very small, and the piece which does the rolling update itself will be reusable and will be the same controller across AWS and, well, at least GCE. Bare metal is obviously a little weirder for this scenario, but
so I believe, I think from SIG cluster API, I think when you say that would support rolling upgrade, I think you mean that it can basically tear down the whole VMs, right? Like, is there a way to do rolling upgrades of individual components, like just the kubelets or just the controller manager or just the API server? Or does the SIG think that it's there is no need for it? I'm just like opening open questions here. I don't have a solid use case, but I think we do always when we roll out Kubernetes using Puppet. Puppet has we basically run Puppet agents that basically have a staggered 4-hour window or whatever. So we want a more controlled way of rolling out Kubernetes upgrades for both kubelet, kubeproxies, and all the components in our cluster. And that's where my questions are.
I don't know of anyone that's done it's actually implemented the full rolling update of a cluster in the cluster API, but yes, it would incorporate that. I think the other piece that is also in there is OS upgrades. So when you have a new kernel version, there's a problem, right? So that also has to come in, and that's why I think we're talking about it currently in terms of replacing VMs and sort of the immutable infrastructure idea. But there is certainly also a need to, like for API server, you don't have to replace your VMs to run a new version of API server. But I don't know if anyone's actually looking at that right now.
So again, inside of the provider-specific config of the cluster API, you can just put like in place true or whatever parameter, and then kubedm, if you install it with kubedm, can go and upgrade like the individual masters in place without tearing down any VMs. Because it's assumed that your cluster API controller will just be able to SSH or whatever into the masters and execute that. So that is like, it's really up to you, but the cluster API spec is going to make it possible to actually specify this as a desired state and reconcile however you want. And the default, as Justin said, as we treat pods, replica sets, and deployments, are to like kill pods and make them come back up. And if we apply that, the machines needs to tear down and bring up new ones. But we can still like create a mode, or you can create a mode like to instead just in place go to the parts and fix them, for the analogy. So yeah.
So one of the things I was thinking is that self-hosting was probably one of the ways that we could do it, because then we could use Kubernetes rolling upgrades to actually do rolling upgrades of components that we deploy using Kubernetes. Is that something that is in line with what the SIG might be thinking, or SIG cluster API is the way to go, and self-hosting is just a toy that we had and we'll never take that any further?
I can speak to a little of this, which is, so first, it's a cluster API is a sub project of this SIG, so it's not a separate SIG. But there was, I don't know whether there were certainly efforts at doing full self-hosting of things like etcd, which I believe we are backing away from at the moment, at least because of some of the complexities around the failure modes around that.
Yeah.
I don't know if anyone is looking at other forms of self-hosting that are less complete, as it were, or less like circular. But but that could certainly be a mode of operation in the cluster API. The cluster API, as it stands today, is certainly, like Lucas mentioned, the provider config. It has an extension mechanism that is open-ended enough that it leaves those sort of things undecided, as it were. So there will be some people or some implementations, I hope, that try some form of self-hosting, and some implementations that try some form of not self-hosting, where we use static pods as we do today.
Mhm.
So I would say that when you ask for self-hosting, KubeADM is moving away from it because
Yep.
of the design decision we mentioned earlier at this meeting, that we are very implicit, and like where we're executing, we can change stuff, and we don't go and we don't make KubeADM change stuff on other nodes, for example.
So just to clarify,
yeah.
we're very explicit.
Exactly.
There can always be a separate tool like a pivoter that could be created that could pivot from static manifest to self-hosting in a controlled fashion. And we're totally probably be supportive of somebody working on something like that, but we're not going to take it as an effort inside of KubeADM to do the pivoting and maintenance and management of self-hosting, because it conflates the complexity inside of KubeADM itself. We already have 2 control flow paths for a lot of different stuff, and we want to eliminate it back to 1. But 2 is that there are extra circular complexities that exist in self-hosting, as Justin called out, that you get into chicken egg problems that become really difficult to solve, and there aren't easy answers today or ever to solve those problems.
So the answer is yes, you can do it. It's an okay idea if you're aware of the circular dependencies and if you manage it yourself.
Right.
But still, you would probably expose that using the cluster API, like user interface or API.
Sounds good. So I think it sounds like that cluster API is the tool I should look at in the long run. I guess I've seen that it's not like it's very alpha stage right now. It's like it's still being designed. But right now we don't have a tool that allows you to control rolling update of individual components of the control plane, right? Is that
There are many tools, is the answer.
true understanding?
And, yeah,
Okay.
there isn't a grand unified field theory for this. There are many tools. People have every tool you can think of for managing their clusters.
Okay, cool. I think we have to.
Okay.
I think we have to end this meeting, but if people want to jump on like spontaneous meeting quickly after this, I'm to extend and talk about. So I just can briefly talk about the config changes as people asked for that. I'm happy to do so, but we should end our official meeting here. Bye.